So we're going to talk about basically right triangle trigonometry here. Some of the stuff you've learned in algebra, some you actually started learning in geometry, right? So for example, first of all here, when we have a right triangle, you've seen these ratios before, right? Sine, cosine, tangent. Now, remind me, did you also do cosecant, secant, and cotangent last year? Okay, good. So we know that these are just ratios, right, of two of the three sides of the triangle, right? So we know sine is opposite over hypotenuse and so on. Anybody need a refresher on that? I think we're good. One thing I want to highlight is the following. So in this triangle, which is the largest side? The hypotenuse. So here, when I have opposite over hypotenuse or adjacent over hypotenuse, is that ratio going to be equal to 1, less than 1, or greater than 1? Less than 1. And then when I have cosecant, secant, and cotangent, what is that going to be? Always greater than 1. And what about tangent? If it compares opposite over adjacent, is there a restriction on that? Can it be less than 1? Yeah. Can it be greater than 1? Can it equal 1? Opposite over adjacent? Can this equal 1, that ratio? It can for isosceles right triangles. So if you have, let's say, like a 45, 45, 90, remember, this could be like, yeah, 4, 4, 4 root 2. So this could be, these two could be any number, or any value, rather. Okay, these two can be any value. Okay, so the cosecant, secant, and cotangent functions are also called reciprocal functions because they are the reciprocals of sine, cosine, tangent. So you might see them written in this way. Cosecant is 1 over sine, and then whenever in math we see 1 over something, it just means reciprocal, flipping over the fraction, right? And then there is another fun fact. Tangent can also be written as sine over cosine. Cotangent, cosine over sine. And these are going to be very important the further out we go. All right? Okay, any questions so far? Okay, so here, find the exact values of the 6 trig functions of theta. Exact values means what? Decimals or no decimals? No decimals. Okay. So all I need you to do is just say sine of theta. Which one is the opposite of theta? Here. 33. Adjacent. Which one is the adjacent? 56. Okay. So sine of theta then is 33 over. Good. And what's cosine of theta? And then here, if you can simplify the fraction, you do. Otherwise, just leave it. Tangent, 33 over 56. And then once you have this, cosecant is the reciprocal. Secant is the reciprocal of this one. And then cotangent is 56 over 33. Okay? So, if you take a look at this, tangent is sine over cosine. Let's just try this out for a minute. So if it's sine over cosine, okay, what was sine of theta? It was this, right? What was cosine of theta? This. I'm just showing you guys this, right? So now, how can you simplify this? Okay, couple ways. One is this divided by this is times the reciprocal, right? You guys remember? If you divide two fractions, okay? So these go away. What do you have left? 33 over 56, which is what we got, right? So I'm just illustrating that that's how it works. Okay? That's all. Okay. You don't have to do it that way, ever. Like the way we did it in the purple was just fine. Okay? All right. So this is important. Not that there's anything that's not important, but this you see a lot. So if you're given one trig ratio, you need to find the others. Okay? Sine of theta is 1/3. Now, sine we know to be opposite over hypotenuse, yes? So here I can literally say this is opposite over hypotenuse. Okay? So now I need to find cosine, tangent, and blah, blah, blah. My first step is I draw a right triangle. Okay, so here. And label one angle theta. Doesn't matter which one's which. So now, if sine is 1/3, that means the opposite side has a length of 1. The hypotenuse has a length of 3. Okay? Now, to find the other ratios, all we need to do is find the missing side. Yeah? So let's find the missing side. How do we do that? Is it 1 squared? Correct. 1 squared plus x squared is equal to 3 squared. So x squared is 9 minus 1, which is 8. So if x squared equals 8, what's x? Root 8. Yeah, so this is root 8. Now, can you find all the other ratios? Yeah, okay, so we know sine, so we'll just do cosine. Okay, tangent is what? Oh, okay. Root 8 is not simplified. We need to simplify it as 2 root 2 over 3, please. Okay, so 2 root 2. So what's tangent of theta? What do y'all think? Say it louder, say it louder. Okay, now, last year, you weren't allowed to leave it like this, right? Okay, starting with pre-calc, we allow you to not rationalize the denominator. And this is like a big thing every year. You don't have to rationalize the denominator. You can leave it as 1 over 2 root 2. We're not okay with this in algebra 1 or intermediate algebra 2 or intermediate algebra, whatever. But starting with the pre-calc, trig, we're good, okay? So you just can't have 1 over root 8, but 1 over 2 root 2 is fine. And at the beginning, everybody just wants to rationalize because you're just so in the habit of doing that. It's fine. So either way are fine with me, okay? Yes, all right, you've made it. See, it's like the big leagues now. So cosecant is 3 over 1, which is just 3. Secant is just this, and we leave it. And then tangent, 2 root 2 over 1, which is 2 root 2.
You have to write the other C for this.
Oh yeah, you do. It's so exciting. But notice, oh my gosh, see, I'm just so excited. But okay, notice how I give I might drop one of these letters because I'm so excited, but I never drop the theta because that's just wrong math, right? So make sure you keep the theta there. Yeah, Jack, right?
Is it possible for you to turn off one of the lights because I can't really see the board?
For cosecant, like, isn't hypotenuse over opposite? So wouldn't it be 3?
For cosecant?
Oh wait. Yeah.
So I did the reciprocal of the sine. Let me see which one is the better version. Which one? The first version? No, not this. We can't learn math like that. Okay.
Thank you.
Okay. We're good, Sam?
Yeah.
Okay. So, special angles, right? 30, 60, 90. You guys remember the 30, 60, 90, right? So this is the way were given, the 30, 60, 90, remember you have three sizes of angles and you have three sizes of the sides. The smaller angle is opposite the smaller side, and everything is based off of that. This is root 3 times that, and then 2 times that, right? So, the way we normally just draw, the way we draw a default 30, 60, 90 triangle is the shortest side, we always label 1, because that's everybody's favorite number, okay? And then the long side will be 1 times root 3, and this will be 2 times 1. So, if you forgot, in the triangle to the left, you've got the short side. The longer leg is the short times root 3. The hypotenuse is 2 times the short. Okay? And then if you have a 45, 45, 90, you've got legs of equal size, right? So you've got leg, leg. And then this is leg times root 2. So the default that we always draw is 1, 1, because 1's our favorite number, except from 0, but you can't label this 0. 1 times root 2. Okay. So, now, if, you're walking down the street and someone taps you on the shoulder and they're like, hey, what's cosecant of 30 degrees? You immediately just refer mentally to these, right? You go, okay, well, this is what a 30, 60, 90 triangle looks like. And I know that cosecant is what over what? Hypotenuse over opposite. So that's 2 over 1. Which is just 2. Now, there is, I have to warn you, a chart, right? It's like, there's a chart of like, this is theta, 30, 60, blah, 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 right? There's a chart out there of these things, yes? And I know many schools and many teachers and many tutors, family, friends, whatever, like to teach the chart. We are not a fan of that chart, right? Because the chart, yes, on blind problems like this, you might be able to figure it out. But then when you put it in context of a deeper problem, then the chart is actually more crippling than helpful, right? I know exactly that nod. I've known that nod for 20 years. I know that nod. Okay? Okay, so just visualize. So like, here's how I would do it. Like when I was in high school, here's what I would have liked to do, right? It's like, okay, sine of 45 degrees, right? Oh, what does a 45, 45, 90 look like? Okay, it looks like this. So sine of 45 must be 1 over root 2. Okay? All right. So here, we want to compare using these symbols, tangent of 60, cotangent of 30. Okay, so I say to myself, right, I'm just going to draw one here, right? 1 root 3, 2. I'm just doing this, and some people just visualize and see this, right? So, tangent of 60 is what based on that? Root 3. And what about cotangent of 30? Huh?
Yeah, they're gonna be the same.
Right, so we're just, right, so it's going to be root 3. So these are equal to each other. So we have to figure out what tangent of 60 is, right? Right, which is root 3. And what's cotangent of 30? Adjacent over opposite. Cotangent of 30 is adjacent over opposite, root 3 over 1, so root 3.
Does it matter?
Because if you go here, look at what cotangent is here. Cotangent. That's tangent, that's cotangent, so look at, yeah.
Does it matter where you put the theta? Like, where you choose like the opposite, or no, it depends on
the angles.
Wait, then how is tangent?
So they're tangent and cotangent of different angles, that's the thing. Yeah. Okay, so what's cosine of 30? Other one. Root 3 over 2. Right? Cosine of 30 is adjacent over hypotenuse, root 3 over 2. Okay. What about secant of 45? Root 2. Okay, now, you don't have a calculator, and you have to figure this out. We don't need to know exactly what decimal value each one has. So let's think about this for a minute. I have a root 2 and a root 3. Between a root 2 and a root 3, which one's bigger? Root 3 is bigger. Then if I divide that by 2, though, now what happens in comparison to the root 2? It'll be smaller, right? So this is the smaller value. Is that okay, or should we go over that again? Huh? Does it make sense? I mean, it's math. It always makes sense, right? It's got to make sense, right? Okay, so this is where that chart I was telling you about will not help you, because here we have a 45, 45, 90 triangle, and we have to find these, so we have to know the comparison of the sides, right? Well, if you have a 45, 45, 90, how do those two sides compare? They're equal to each other, so in this case, I can just say x squared plus 4 equals 6x minus 5, and then solve. And in another problem, like in the one in your homework, it's going to be a 30, 60, 90 triangle, so you just have to set up that relationship. So, and now this is like, you know, an innocent algebra 2 problem, right? Remember these? Now we factor. This is x minus 3 squared equal to 0. So x is equal to 3. Okay? All right. Let's solve some triangles. All right. So suppose a competitor in the swimming portion of a race is swimming along the course shown. Find the distance the competitor must swim here in order to reach the shore. So immediately you see this as, okay, this is a right triangle, right? What are we given? Opposite and adjacent and an angle. So that's what? Tangent of 40. So tangent of the angle is opposite over adjacent. Multiplying both sides by 75. 75 tangent of 48 is equal to x. This you need to plug into your calculator, right? So go ahead and take them out. What should the calculator be in for this problem? Radian or degrees? Huh? Degrees is right. You guys all know how to switch back and forth? Right? They toggle here if you have the right. So I will always specify on tests for here, let's round to the nearest foot. Nearest foot, nearest whole number. If you bring your cursor up here to where it says radian or degree and you click on it, it toggles back and forth.
Yeah.
Looks like people are getting 83 feet.
Wait, how do you, when do you do degrees or radians?
So in this case, the angle is given to you in degrees.
Oh, so it's just depending if
It depends on the problem. Now, what if you have to find a missing angle? In that case, we need to use what we call inverse trig functions. Did you guys also use these last year? I think you did. Right, sine of -1. Whoops. So inverse sine, inverse cosine, inverse tangent is how we find the angle. So this problem asks to solve the triangle, and when it says to solve the triangle, so how many sides to a triangle? And how many angles? 3. That's 6 items total, right? 6 quantities total. To solve the triangle, you will be given 3 of the 6, and you need to find the missing 3. So here, I'm given a side, an angle, and another angle, G. I need to find angle H, and I like to make a list for myself. I need to find angle H, side F, and side little h. Yeah? Okay, so angle H is easy here. How much?
48.
Right. Okay. Okay. Now, okay. Let's find F first. I like to, no matter, even if I found the other missing angle, I like to use what the problem gave me in case I made a mistake, so it doesn't, my problem doesn't, go off the rails. So here I have an angle, opposite and hypotenuse. That sounds like what? Sine. So I will write sine of this angle is equal to F over 28. Right, so F is 28 sine 41.4. And let's look in the problem here. It says to round side lengths to the nearest tenth and angles to the nearest degree. So this angle should have been 49 degrees. Okay, so what's this side F going to be? Did anyone do it? Raise your hand if you found F. Yeah. You got the right answer then. So 18.5. How are we going to find the other one? Okay, so you can either do Pythagorean theorem or you can do another inverse cosine. I'm not going to lie, I prefer the trig functions because it ends up being like less computation if you think about it, right? Rather than doing like all these like decimals squared plus decimal. Oh my god, I hate plugging that stuff in my calculator, right? So okay, so what is this? Round. So what are we going to do? Cosine. I'm going to use the angles they gave me just in case I made a mistake.
Wait, I don't think that's an angle. You wrote F as an.
Oh yeah, I did. Thank you.
I keep getting -14.
Oh, let's see. So it's h over 28. Did you do cosine?
Oh. Wait, no, I mean for F. Like for sine.
Oh, okay. Are you in radian or degrees? You must be in radian. Yeah?
Okay, I don't know how to change.
No. So, escape. Take the cursor on top of the radius.
Oh, yeah.
Here, on top of the radius.
I gotta remember it.
Now press the center button. Oh, this one doesn't. It depends on the. Okay. No, it's okay. It depends on the operating system. So go here, go to settings, number 7. You can also press 7.
Oh.
And then document settings, number 2. And here, change it to degrees. So click on the arrow.
Yeah. Do you want us to try like a 0.0 or do you want to just?
Okay, best question ever. So this one says you get 21, right? But you have to go to the nearest tenth. So yes, put a 0. Okay? 21.0. Because If you just put 21, it could be 21.1, 21.2, 21, right? So you have to specify that it's 21.0, right? Yes? Okay. Okay. This is the fastest I've ever done this lesson, I think. How is it so far? Not too bad.
I can just stay with this. Yes.
Huh?
Yeah. I can just stay with this.
And here, okay, so last time I was like, oh my gosh, I should have like done lesson 1, but okay.
I think we learned it at the very end.
I think it's better that we did lesson 1 on this, like, second.
Yeah.
I need to record some of this stuff.
Okay. Huh?